In this video, I will show you how to use our double angle identities to solve trigonometric equations such as these. We're going to be solving for x over the interval 0 to 2 pi. So I see a double angle right here, sine of 2x. So let's see what the identity is for that. So the sine of 2a equals 2 sine cosine. So I'm looking at this, I'm thinking this part right here is going to become 2 sine cosine. So I'm going to have radical 3 cosine x is equal to negative. Now here comes my 2 sine cosine. All right, let's get 0 on one side by adding this entire term to both sides of the equation. In other words, I'm going to move this to the other side of the equation by addition. That will give me radical 3 cosine x plus 2 sine x cosine x is equal to 0. By the way, on that previous step, it might have been tempting to divide both sides by cosine x. All right, you see both sides have this cosine x, so maybe we can divide by cosine, cancel those out. Do not do that because cosine x sometimes will have a value of 0, and then you're dividing by 0 and you break the universe. So never divide by a trig function. Instead, get 0 on one side, and then that thing that you were tempted to divide by will now be a common factor, which you will pull outside of parentheses. So I'm going to take this GCF of cosine x, put that out in the front. That's going to leave me with radical 3 plus 2 sine x is equal to 0. According to the zero product property, I can get solutions by setting either of these factors equal to 0. So cosine x equals 0, which is why we couldn't divide by it. And then we have radical 3 plus 2 sine x is equal to 0. Okay, I need to get sine x by itself. So I'm going to subtract the radical 3 and divide by 2. So I'm going to end up with sine x is equal to negative radical 3, that's the subtraction part, over 2. There I divided by 2. What are the solutions to each one of these equations? All right, this first one is going to be a quadrantal angle. All right, where is cosine 0? In the back of my mind, I'm picturing this. And over here I have 1, 0, and then 0, 1, negative 1, 0, 0, negative 1. You should not have to draw this. You should just think about it in the back of your mind. Cosine is the x value. So where does the x value equal 0? That's up here at the top and down here at the bottom. In other words, pi over 2 and 3 pi over 2. So I get x is equal to pi over 2 and 3 pi over 2. That's what I have so far. What about this? The sine of what angle is equal to negative radical 3 over 2? Well, what's the reference angle, first of all? The sine of what angle is just plain old radical 3 over 2? Let's see. So remember, you should have this chart memorized by now. So here's sine, and here's radical 3 over 2. So the sine of pi over 3 is radical 3 over 2. Okay, so we know the reference angle is pi over 3. But there are actually 4 angles that have a reference angle of pi over 3. any of these angles will give me some kind of radical 3 over 2. It's just that the sine function is positive in the first and second quadrant and negative in the third and fourth quadrant. In this case, sine is a negative value, so we should only be looking at this position and this position. Remembering that the reference angle is pi over 3, right? Maybe I should make a little note of that, show some respect. Reference angle is pi over 3. This angle right here is going to be 4 pi over 3. And in my mind just then, I was thinking to myself, look, on the far left, this is of course pi, and that's the same thing as 3 pi over 3. That helps me remember that the next spot is 4 pi over 3. In a similar way, on the far right, this would be 6 pi over 3, which helps me remember that this is 5 pi over 3. You should be able to do all of that in your head. You shouldn't have to draw either one of these two pictures. All right, I'm just showing you what I'm thinking. Anyway, we're going to add these solutions to the list. So in addition to the two answers we already have, we will add 4 pi over 3 and 5 pi over 3. So these are the solutions to problem number 8 between 0 and 2 pi. Let's look at problem number 9. Okay, I'm seeing this sine 2x again. Remember that the sine 2x equals 2 sine cosine. So let's rewrite this very carefully. So I have negative 2, and then I'm going to have times 2 sine cosine. All right, I just replaced sine 2x with this 2 sine cosine part. But I still have the minus 2 cosine x. Now I have negative 3, and again, sine 2x, that's going to be 2 sine cosine. So I'm going to have 2 sine x cosine x. Simplifying a tiny bit, I have negative 4 sine x cosine x minus 2 cosine x is equal to negative 6 sine x cosine x. Let's go ahead and move this to the other side of the equation by adding 6 sine x cosine x to both sides. I think I'll actually show it this time. So we are adding 6 sine x cosine x to both sides of the equation. Notice that we do have like terms here, so we might as well line them right up. So this will give us 2 sine x cosine x minus 2 cosine x is equal to 0. Time to factor out the GCF. I see that both terms have a cosine x, but they also both have a 2 in common. So the GCF is going to be 2 cosine x. So let's go ahead and pull that out. That's going to leave behind sine x minus 1. And this all equals 0. So I will be able to get solutions by setting each factor equal to 0. So if I set 2 cosine x equal to 0, and then I set sine x minus 1 equal to 0. Dividing both sides by 2, I get cosine x is equal to 0. And then adding 1 to both sides, I get sine x is equal to 1. These are both going to be quadrantal angles. So you should be able to picture this in your mind, but you can't read my mind, so I'm just going to go ahead and write it on down. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cosine is an x value. So this is asking, where does the x value equal 0? Well, that's up here at the top and the bottom. So I've got pi over 2 and 3 pi over 2. Where does sine x equal 1? In other words, where does the y value equal 1? Well, guess what? The only place where the y value equals 1 is again up here at the very top. So that's again pi over 2, which we already had. So that doesn't actually add any additional solutions. That means the two solutions that I wrote down in the first place are the only solutions. Problem number 10 involves the cosine of 2x. This is always interesting because if I look at the cosine of 2x, I have three different possible formulas for that. So there's a formula that only involves cosine, there's a formula that only involves sine, and then there's a formula that has one of each. So you have to be a little bit strategic in choosing which one you want to use. So in this case, if I look at the rest of the problem, I notice that everything else has the sine function in it. So it would be wise for me to go with the version that involves the sine function. So I'm going to use the third one. Cosine of 2x is equal to 1 minus 2 sine squared. Okay, so I'm going to take this and I'm going to replace it with 1 minus 2 sine squared. Here comes the rest of it, plus 3 sine squared plus 2 sine is equal to 0. We've got some like terms happening right here. Let's put those together, and I'm also going to take this 1 and I'm going to move it to the end where it belongs. Negative 2 plus 3 is positive 1. So I'm going to have sine squared x, right? That's 1 sine squared x, except I'm not writing down the 1. And then I'm going to bring down my 2 sine x that's right here. And then I'm going to put down the 1 that used to be in the front. This is a trinomial. So this is probably going to factor as a binomial times a binomial. So let's get ready for that. Looking at the first term, sine squared x will only factor as sine x times sine x. Split that up. Now I'm going to skip the middle for now. Look at the third term. The number 1 can only factor as 1 times 1. That makes this very easy. Listen to the phrase I'm about to say. Inner plus outer equals middle. Here's what I mean by that. Inner, I'm talking about these two terms right here. If I multiply those, I get 1 sine x. When I say outer, I'm talking about these two terms. All right, if I multiply those, again, I get 1 sine x. Inner plus outer must equal the middle. The middle is this right here that I skipped a minute ago. Okay, so the inner plus the outer must equal 2 sine x. Notice that I haven't done anything with the signs yet. I left it blank. We can choose whether we want these to be positive or negative. But since the middle has to be positive 2 sine x, that will only happen if both of these are positive as well. So that means this has to be positive and this has to be positive. So there we factored it. We will use the zero product property and set each factor equal to 0, except these are actually both the same thing, so we don't need to do it twice. So I'm just going to take the sine x plus 1, set that equal to 0. Subtracting 1 from both sides, we have sine x is equal to -1. This is going to be a quadrantal angle. Do this part in your head, please. I've got 1, 0, 0, 1, -1, 0, 0, -1. Sine is a y value, so where is the y value equal to -1? Only here. X is equal to 3 pi over 2. All right, this will be the last problem on this video. I see that we have the cosine 2x happening. If we look at the double angle identities, remember that the cosine has 3 different variations. One with cosine, one with sine, and one with both. So which one are we going to pick? Elsewhere in the problem, we have cosine. So let's pick the one that only has cosine in it. So cosine of 2x is equal to 2 cosine squared minus 1. So we're going to take this and we will replace it with 2 cosine squared minus 1. Now here comes the rest of the problem. So I'm going to have plus 5 cosine x is equal to 2. Let's go ahead and subtract 2 from both sides. We're going to get 0 on one side. So obviously this will make -3, but I'm going to actually put that at the end because we want this in standard form. So I'm going to take my 2 cosine squared, keep that in the front. And then I will write my plus 5 cosine x, and then the -3 goes on the end. This is a trinomial, so it will probably factor as a binomial times a binomial. Let's start with the first term, 2 cosine squared. This will only factor as 2 cosine x times cosine x, right? If we multiply these together, that makes 2 cosine squared. That's the only way to do it. Skip the middle for now. Look at the last term. Ignore the negative sign. The number 3. The number 3 can only factor as 1 times 3. In this case, it makes a difference whether we do 1 here and 3 here, or whether we put the 3 here and the 1 here. All right, that will give us 2 different answers because of the 2 here in the front. So this is going to be a tiny amount of trial and error. The key is inner plus outer equals middle. If I write it this way with the 1 here and the 3 here, inner is these 2 terms. If I multiply it, I get 1 cosine x. Outer is these guys. If I multiply those together, I'm going to get 6 cosine x. Inner plus outer must equal the middle. The middle is this. Okay, so I need to end up with 5 cosine x. What do the signs have to be to end up with a positive 5 cosine x? Well, I would need a -1 and a positive 6. That translates into a negative here and a positive here. We have to check one thing before we declare victory. Does -1 times positive 3 equal -3? Yes, it does. So in that case, that's it. We have correctly factored this thing. Now, let's take a quick look at what if we had chosen the other way. So what if I had my 2 cosine x and my cosine x, all right, that's how we started out. But what if instead of putting the 1 and then the 3, what if we put the 3 and then the 1? How would that turn out? Inner, I would have 3 cosine x. Outer, I would have 2 cosine x. Inner plus outer must equal the middle. The middle is 5 cosine x. So right now it's looking like this would also be possible. To get a positive 5, all I have to do is leave this as positive and leave this as positive as well. That would mean that both of these would have to be positive. But here's why this is wrong. You always have to take one additional step and make sure that when you multiply the constants, if I do positive 3 times positive 1, is that going to give me negative 3? Obviously the answer is no. That's why this one doesn't work, because this would give me a positive 3 when I need a negative 3. All right, so don't forget that one last little step, because every now and then it's the step that makes the difference. Anyway, this was the correct factorization. We will find the solutions by setting each factor equal to 0. So adding 1 and dividing by 2, I'm going to get cosine x is equal to 1/2. Subtracting 3 from both sides, I get cosine x is equal to negative 3. Interesting. Come back to that in a second. Cosine of what angle is equal to 1/2? Well, the reference angle here is pi over 3. Okay, that's the reference angle. But this is the picture that you should be imagining. There are 4 angles that have a reference angle of pi over 3. There's one in every quadrant. Cosine is positive on the right-hand side, and it is negative on the left-hand side. In this case, the cosine is positive, so we want these two positions. We want these two. With a reference angle of pi over 3, that means we're dealing with pi over 3 and 5 pi over 3. All right, in my mind just then, I was thinking that pi is the same thing as 3 pi over 3. And 2 pi over here is the same thing as 6 pi over 3. That helped me remember that this would be 5 pi over 3. So anyway, these are the two solutions, pi over 3 and 5 pi over 3. Okay, so we have x is equal to pi over 3 and 5 pi over 3. But what about the cosine of x equals negative 3? That looks really weird. Except when you remember that the maximum value of cosine is positive 1. Remember that cosine is an x value on the unit circle. The highest possible x value is over here on the right-hand side, where the cosine is equal to 1. The x value is 1. And the lowest possible cosine value is over here on the left. Right? This is the smallest x value you can get on the far left. And that's where the cosine is equal to negative 1. So cosine has a maximum and a minimum of positive 1 and negative 1. There's no angle that will ever give us a cosine of negative 3. Okay, this has no solutions, so we will just ignore it. So the only two solutions are pi over 3 and 5 pi over 3. Look, in the next video, we are going to talk about verifying identities involving double angle identities. So if that sounds interesting to you, go ahead and watch the next video.